Ooh. Hello, everybody. Oh, it did work. Welcome. We're going to be talking about for loops, and I got some slides for my AP Comp Sci class because I think they do a pretty good job of explaining what a for loop is. Make no mistake, while loops are everything you could use. You never have to do anything different than a while loop if you don't want to, but gosh, a for loop was invented really as a shortcut syntax to make writing loops shorter and easier. You have to learn a new thing, but it'll be worth it, I think, in the long run. So let's learn about the for loop. Here it is. This is sort of the basic structure of it. So instead of while, you say for, and then it's got, instead of like the condition, it's got three pieces inside those parentheses. The three pieces are the initialization statement, the Boolean expression, and an iteration statement. So let's take a look and see what that looks like side by side with a while loop. And apparently I can't point with my mouse, so I'm not super happy about that. Didn't realize that would be the case. We'll take a look over on the left here. We have a while loop. The system.out.println, you can just read as println. This was made for pure Java, and that would mean you'd have to write println that way. So just ignore that. It could just be a println in processing. But everything else is exactly the same as in processing as it is in Java. We have a while loop, and that looks pretty familiar probably from the while loops we've been working on. As you know, a while loop has a condition. It's in the parentheses. In this case, it's x is less than 10. And that's the condition under which it'll continue to repeat. If that condition is true, it'll do that block of code, the print line and the x++. It'll do that again and again and again as long as x is less than 10. And again, when it gets false, then the loop stops. So that's fine. That's a nothing new. And the output of that, of course, will be, x will start at 0. So print 0, and then 1, and then 2, and then 3, and so on. Eventually, it'll print out 10. X will increase to 11, and then that will stop the loop. So we'll see 0 through 10 printed on the console. Now take a look over on the right-hand side. You'll see a for loop. It's like, I guess if I was in the video, it'll be right above my head. So the for loop is basically exactly the same components. We've just stuck all the pieces in one place. The int x equals 0. Do you see where it is? Do you see where the x is less than 10 is and where the x++ is? We all kind of just move them into that place where normally in a while loop our condition is. So again, it's like a shortcut for that particular kind of loop where we are counting from some starting number to a known end number, or at least an end number we can calculate, and we're going up by a predictable pattern of numbers. So in this case, going up by 1 each time. For loop is a nice shortcut for that. So it's just like, if the case that's not clear, let's look at some diagrams here. I'll show you here. So on the while loop on the left, you can see we've moved that initialization, the int x equals 0. That's our counting variable. And we normally put it outside. No big deal. Now we've moved it inside. The only thing that we have to remember is, because that's kind of obvious that it's not repeated in the while loop because it's not inside the while loop, but now it's sort of inside that for loop. But remember that it only happens at the very beginning, just like the while loop. These two blocks of code, these two loops, are identical in every way in terms of how they function. So that's the initialization statement. We just stick it inside the parentheses. The next part is, I guess there's a little details about scope. Not a big deal. The scope of x is only inside of the for loop when you use it in a for loop. You can't use x outside of that for loop. Not a big deal. I don't think it'll really come into anything we need to know for this coming up project. So the next part here, this Boolean expression is the condition, right? It's the thing that decides whether the loop continues to run, and that's in these parentheses as well. We've just kind of moved it over, and it hasn't changed at all in any way. So I guess it's got some semicolons around it, so keep notice of that, but otherwise it's the same. And then last but not least, that x++ that normally happened at the end, we call that the incrementation step. That is now put into the for loop body. And that's great because it's always going to happen at the very end. Have you ever forgot to put in an x++? Have you ever forgotten that in a while loop? Or whatever the variable is, I++? That happens often. We get like an infinite loop when that happens. And in a for loop, it's just harder to forget it because it's right up there. It's right at the top. And it's easy to see your code because sometimes that x++ gets hidden in all the braces, or we accidentally leave it out of a brace when we make a new if statement or something inside of our loop. So that's a really handy and error free isn't quite the right word, but like less prone to error place to stick our incrementation step. Make no mistake, it still happens at the very end after the print line has happened, and any other statements that are in that block of code, it'll happen at the very end of our loop. No matter, in the while loop, we could technically have placed it anywhere, but in for loops, it's locked in at the end. But guess what? That's probably where we want it to be anyways. So for loops are fantastic for that. Does that make sense, folks? Is that pretty clear as to how that's working? So I'll just switch over to processing, and I'm going to have you take a look at something and then pause the video and try it out yourself. So I'm going to make just a quick new sketch, and then I'm just going to type out a while loop, and then I'd like you to pause the video, think about what the conversion to a for loop would be, type it out or write it on paper or whatever you need to do, and then run the video again to see what the answer is. So what if I started something like this? Int I equals 10. Well, I is greater than or equal to 0. Print line I, and do I minus minus. So here's a while loop. It's going to start I at 10, and it's going to continue as long as it's greater or equal to 0. It's going to print out that number, and then it's going to decrease it. So if I run this piece of code, not surprisingly, oh, that's off. Wow. That jumped. that zoom. You can see it counts from 10 down to 0, right? Going down 1 each time. Not sure how I zoomed in so fast. So now the question is, what would that look like as a for loop? Go ahead, give it a try. I think it's really important to actually try it right now. Don't just keep the video going. Don't do it. Press the pause. Give it a try. Okay? Okay, so I assumed you paused the video. Now I'm going to show you the answer. Here it comes. So as a for loop, this would appear like so. I would start with the for loop. Int I equals 10 would be here. I'll put a semicolon, and then I'll put in the greater than or equal to 0 part, and then I'll put in the I minus minus part, and then I'll put in the body print line I. This is effectively the same. The only problem is, oops, that I already exists. And actually, this is a pretty awesome thing about for loops. If this was a for loop, the scope of I would only be inside of it, so I wouldn't have to make a new variable here. So that's kind of cool. So maybe I'll just make this J, just to avoid the collision of variables. But if I was to use J again, if I say int J equals 30 or something, that would actually be okay. This is a warning. It's not an error. I could say, I could go and do stuff with J because it's only usable in here. For while loops, that I is usable outside of it. So, for better or worse, some people will find that useful, and not all the time will you find that useful. There you go, folks. For loops. I hope you find them useful, and we're going to put them to use for sure for our next topic, which is going to be loading our map into our world. We're actually going to nest 2 for loops together so we can drive 2 variables, an X and a Y coordinate across our image and load in that stuff. All right. Thanks, everybody. See you later.